Okay, we made it to our last section of trigonometry, section 6.4. This last section talks about two concepts. The first thing we want to do is learn how to take a trig equation and rewrite it as a trig inverse equation. So that's what we're going to focus on first. So if you look here, these are trig equations. Y equals 5 cosine x. Y equals 6 sine x over 4. What you'll notice that's different with these equations versus the ones we've been working on is they're using x's and y's. Okay? We just don't have theta or just x. And the directions say to rewrite these as trig inverse equations, which means instead of having the function cosine, I want the function cosine inverse. Instead of having the function sine, I want the function sine inverse. So the way we're going to do that is exactly how we would think about doing anything else. We're going to move any numbers we can move over to isolate the trig function. And then to get rid of the trig function sine or cosine, we're going to apply its inverse. Okay? Just like we've done all along in any math class. If you want to get rid of a square root, you isolate it and then you do the opposite, square. To get rid of a square, you isolate it and do the square root. Back in college algebra, if you had an absolute value equation with the bars, you isolated them, then you got rid of them. So it's the same concept here. So the first step to write a trig inverse equation is isolate the trig function. So if our trig function is cosine x, we want to isolate it, so we'll move this 5 by division, which makes sense. And this would be y divided by 5 equals cosine x. Now, our job is to write a trig inverse equation. So we want to get rid of the word cosine by doing its inverse. So what we're going to do is we're going to say, okay, the opposite of cosine is cosine inverse. Now, we're not going to write cosine inverse x. We want the x to stay there. We just want this word to cancel. So the opposite of cosine is cosine inverse. And we all know what we do to the right, we do to the left. So now the left becomes cosine inverse of y over 5. So now this, if you think about what inverse means I'm giving you a number, you're going to spit me an angle. This is your number connected to cosine inverse. And on the right here, this word and this word cancel out and leave you x. This is your inverse equation. X equals cosine inverse of y divided by 5. Or it can be written as x equals cosine inverse of 1/5 y. That's your goal, is to get x by itself. That's the inverse equation. And it will be an inverse equation because you're using a trig inverse. Okay, let's try the next one. This is a trig equation. Y equals 6 sine x over 4. Okay, from our knowledge, we know that's the sine function. We know we can graph that. Okay, we know that's the amplitude. We know we have a frequency. All that stuff from chapter 4. What I want us to do is rewrite this as a trig inverse equation. So instead of having sine, I want sine inverse. When I write the inverse equation, I don't want it y equals, I'm trying to get x equals. So again, the first job is to isolate. Move everybody away from the trig function you can move. So to move that 6 by multiplication, I'm going to do division. So y over 6 equals sine x over 4. Now here comes the boo-boo. Everybody's going to say, well, let's move the 4. Remember, this is a trig function. With a trig function behind it is the angle. The angle is x over 4. You can't take the 4 off the angle. Okay, remember, we can't separate the angle from the trig function. So now what we want to do is we want to get rid of this word sine, and the opposite of sine is sine inverse. And if we do it to the right, we do it to the left to keep balance. So the left side becomes sine inverse y over 6 equals. These are inverses, opposites, they'll cancel out, and that'll leave us x over 4. But now we're not done, because now we can get x by itself. Because the opposite of dividing by 4 is to multiply both sides by 4. And we will get x equals, the x is isolated, 4 times the sine inverse of y over 6. Or another way of writing that is x equals 4 sine inverse 1/6 y. I can't take this 4 that I'm multiplying by and multiply it to this fraction, because remember that fraction now is part of the trig inverse. So it's got to go in front. So that's not very hard to write a trig inverse equation. All a trig inverse equation means is when you look at the equation, it's got the inverse function in it. Okay? Now, our last thing to do is to solve these kinds of equations. All right. So let me get our notes, and let me get example A and show you what we're talking about. Equation A says to solve -4 arc sine x equals pi. Now, when we look at that equation, we know that that is a trig inverse equation. We've talked about old school. When I was in high school and college, they used the word arc to mean inverse. Let's rewrite that the way you're used to seeing this. This would be written -4 sine inverse x equals pi. Okay, so I can rewrite it. If you don't like the word arc, just rewrite it with the -1 exponent. Okay, and the reason why we rewrite it like that, because that's how our calculators are programmed. Your job is to solve for x. Okay, like we've been doing. What I want you to understand is what you're finding. And we're going to get x by itself. All right? So let's talk. To get x by itself, well, x is connected to this trig function. Before we can even get rid of the trig function, we got to move everything over. So there's a -4. So we know we can move the -4 by dividing. Let's isolate. So we get sine inverse x equals, I'm going to float my negative up, and this is pi over 4. So sine inverse x equals pi over 4. You'll agree? We're not done. We're trying to solve for who? X. So we need to get rid of this word sine inverse. So guys, what is the opposite of sine inverse? That would be sine. So on the left side, I'm going to put the word sine, and on the right side, I'm going to put the word sine. These are inverses, so they're going to cancel. X equals. So this is going to say x equals the sine of -pi over 4. Now I know what most of you are going to do. You're going to write that as the answer. Well, you're not done. We're back to chapter 1. I'm giving you a trig function with an angle behind it. I want the answer. So think about this, people. In sections 6.2 and 6.3, when we were solving trig equations, when your trig equation had sine x, cosine 2x, sine 3x, when we solved for x, we found an angle. Now that we're solving a trig inverse equation, we're not going to get an angle. This is an angle, right? There's the word sine, trig function, behind it's an angle. I'm going to get an answer that's a number. So now we know how to do this without a calculator, because we know pi over 4 is 45 degrees. I'm really asking you to look up the sine of -45 degrees. Well, we know what quadrant is that in. That's right, we're in quadrant 4. We know the sine value in quadrant 4 is going to be what kind of number, positive or negative? All students take calculus. Our answer for x has got to be negative. We're in quadrant 4. And we know the sine of -45 degrees is really looking up the sine of 45 degrees, which by now we should know by heart is square root of 2 over 2. So the answer to this trig inverse equation is x equals negative square root of 2 over 2. When we're solving a trig inverse equation, we're not getting a number, an angle as an answer, we're getting a number. Let's try the next one. Let's go to B. 4/3 cosine inverse of y over 4 equals pi. So now the directions say to solve. We're solving for the variable y. So to solve for y, we want to get y by itself. Well, y is part of the trig inverse. So the first goal is to get anything that's not part of the inverse over to the other side. Well, we all know we can move 4/3 by the reciprocal, which is 3/4. So that's what we're going to do. 3/4 times 4/3 cancels. It makes 1. So now we have cosine inverse y over 4 equals, this is 3 pi over 4. All right, I can't get the 4 out of there yet because it's connected to the trig inverse function. So I have to get rid of the trig inverse function. So the opposite of cosine inverse is to put a cosine on each side. Cos, cos. Cos and cosine inverse will cancel out. That'll leave us y over 4. On the right side, I have cosine 3 pi over 4, which makes sense. That's a trig function from chapters 1. I should have an angle behind it. That's an angle in radian measure. We're trying to solve for y. So the opposite of divide by 4 is to multiply by 4. I can't multiply this 4 to this 4 because remember, this is the angle. So it goes in front. Now, that's not your final answer because you got to look this up. You can look up cosine of 3 pi over 4 without a calculator. We know pi over 4 is 45 degrees. So 3 times 45 degrees is 135 degrees. So you're looking up 4 times the cosine of 135 degrees. Well, we know cosine of 135 degrees in quadrant 2. Cosine is negative. We know the reference angle of this is 45, and we know the cosine of 45 is just like the sine of 45. It's square root of 2 over 2. So we learned in chapter 1, if I give you a trig function, and whether the angle is in degrees or radians, if I give you a trig function of an angle, you're to give me an answer that's a number. Now that's not the final answer, because I got to multiply that by 4. So if I multiply my fractions, I get negative 4 square root of 2 over 2. These will cancel their whole numbers, and that would give me y is negative 2 square roots of 2. When I solve a trig inverse equation, my answer should be a number. Just like we were solving regular trig functions, our answers were angles. This is the opposite. Okay? Let's try one more. So this is it, guys. My last example I'm going to do with you. All right. Our last equation is real simple. Cosine inverse of x equals sine inverse of 3/5. Okay. So if I look at this equation, I know it's a trig inverse equation. I see the inverse symbols. Our job is to solve for the variable. The variable is x. Well, this is easy. There's nothing to move at all. There's nothing connected to cosine inverse x. So all you got to do is get this word off that x. So the opposite of cosine inverse is doing a cosine. Doing a cosine. Make sense? This is going to cancel. There's the x equals. This is written on the right side as cosine sine inverse of 3/5. So we've already discussed this in section 6.1. We have two functions going on. We got a trig function cosine, and we have an inverse function sine. We have parentheses, so we do what's in parentheses first. Inverse means I give you the number I want the angle. So here we go, guys. What angle measurement do we get 3/5 from? Is 3/5 on the unit circle? Nope. The only thing you get from unit circles are ones, negative ones, and zeros. Is 3/5 on the 45, 45, 90? Nope. That's 1 square root of 2. Is 3/5 on the 30 or the 60? Nope. Those sides are 1, 2, and square root of 3. So here we go back to the beginning of the semester without a calculator. Now I agree. If I said pull out your calculator, you would type 3 divided by 5, you'd get a decimal, hit sine inverse, the calculator would give you an angle, and then you would do the cosine of that angle. But this is without a calculator. Without a calculator, how do you get the answer to this expression? Well, it goes back to the whole beginning of this whole course. Trig is a relationship between an acute angle and two sides of a right triangle. 3/5 is the sides of a right triangle. Because this is positive, I'm assuming the triangle's in quadrant 1. Here's my angle theta. Sine stands for y over r. If I am in quadrant 1, I could do x squared plus y squared equals r squared. Or if I'm quick by now, I know my triples. This is a 3, 4, 5. I don't have to know how many degrees this angle is. If I can draw its right triangle, I can find the cosine value. The cosine value would be x over r, which is 4/5. Again, why do I know that this triangle's in quadrant 1 and in not quadrant 2? Because we talked about inverse and we talked about the principal values. And when you're doing sine inverse, if the number's positive, we're always assuming the triangle's in quadrant 1. If this number was negative for sine inverse, we would draw the triangle in quadrant 4. So that's why I know it's in quadrant 1 and not 2, because it's based on principal values. Even though I don't know how many degrees actually the angle is, I mark the angle with theta, I can do the cosine of that angle, 4/5. And I just solved a trig inverse equation. So now we are completely done with the course. Now you have the most difficult test to take, because the Chapter 5 and Chapter 6 test is the most algebra intense test. Not only do you have to know how to solve equations and understand the concept of inverse, you have to memorize your principal values. You have to know how to draw your unit circle, your 30, your 45, and 60 triangle. You have to know your quadrantal angle rules. You have to know about positive and negative. All students take calculus. Plus, you got to rely on those half angle and double angle identities, maybe, and the Pythagorean identities, and the ratio identities, and the reciprocal identities. So it's all tied in. So please take your time to practice for this test, seeing it is the most intensive one as far as studying, and I wish you the best of luck. Thank you.